Hi, this video will show us on how to calculate the efficiency of an algorithm. So in the previous section, we have discussed the efficiency of an algorithm with the big O notation. And now, given the code, okay, like given the code of my array that is with the following elements and something like secret function and my array as input, and here total is equal to 0 and return total. So we know that for the constant value like assignment statement, comparative, we have the constant value for that. Now we have the O of n for this statement total is equal to 0 because we are just assigning the value to total variable. And also we have the O of n for returning the total, just like returning the value of the total. So to calculate the big O notation for that, we have to have the t as the time complexity as equal to O of 1 plus O of 1, because these are the statements under the function's secret function. So O of 1 plus O of 1 is, of course, O of 1. So the time complexity for this algorithm is O of 1. Now we have another example, that is printing the value of the elements. Okay, we have here the loop to traverse the array, and here print the value of such element at a specific index. Now we have to identify the time complexity in every statement. First, we have here the O of 1, because how much time will it take for this statement. But for the iteration, it depends on the length of the array. Okay, so for the statement, we have O of 1, but for the length of the array is n. Next, for printing the value of the array of the element is, we have here the constant O of 1. Now, to calculate the time complexity, we have here n times O of 1. That's because we have to depend on the number of the elements or the size of the array. So we have to iterate the loop, okay, depends on the until the end of the elements, okay, for the size. So n times O of 1 plus the big O notation of this statement, it's O of 1. All right. Now, we have to get the fastest going term out of these two terms. Okay, n times O of 1 plus O of 1. So we have n times O of 1. Next, we have to remove the coefficient, that is the O of 1. Okay, because this is constant, so we have the remaining n. So the time complexity of this algorithm is n. Thank you.